Hello everyone, my name is Rajoy Mukherjee and I am a research scholar in the Department of Computer Science and Engineering, IIT Kharagpur. I am funded by Prime Minister Research Fellowship. So I'll be conducting this live session on the NPTEL course, Computers Organization and Architecture. So we'll be solving some sample questions in the form of tutorials and the session will be interactive. So the session is also being recorded and it will be available to all the registered students. So let's start the session. The first question is, what is the binary representation of decimal number 45? So we'll use the standard formula method to do it. So 45 will divide by 2. The quotient will be 22 and the remainder will be 1. Then we will again divide it by 22. We will divide 22 by 2. The quotient will be 11 and the remainder will be 0. We'll again do the same for 11. The quotient will be 5 and the remainder will be 1. Then we will divide 5 by 2. The quotient will be 2 and the remainder will be 1. We will do the same for 2 and finally the quotient will be 1, the remainder will be 0. So this is the binary representation of 45. So we can write 45 base 10 as 1 0 1 1 0 1 to the base 2. So the correct answer is option C. So let's go to the next problem. So the next problem is, express the hexadecimal number AB27 to the base 16 in binary. So we will write the number so this will be, so we will convert each of the hexadecimal digits into their corresponding binary, and that will be the overall binary representation of the hexadecimal number. So A will be 1 0 1 0, B will be 1 0 1 1, two will be 0 0 1 0, 7 will be 0 1 1 1. So the binary representation will be 1 0 1 0 1 0 1 1 0 0 1 0 0 1 1. So the correct answer is option, which one is it? Option A. So let's move to the next problem. The next problem is, which of the following switching expression represents exclusive NOR of two variables A and B? So exclusive NOR can be represented as A XOR B and the negation of it. So A XOR B is basically, we all know it is a very common formula representation, AB bar plus A bar B so this can be represented as A B bar B bar. So this is using the principle of duality, De Morgan's law. A bar B bar. This can be further written as using the same A bar B A plus B bar. So we can further break it down as A bar B bar plus A B. So this represents option C and this represents option B. So this question has two correct options. So the correct options are B and C. So let's move to the next question. Question number 4. So the question is, suppose A equals to 0 1 1 1 and B equals to 1 0 1 0. Will there be any end around carry if we subtract B from A using 2's complement arithmetic? So we need to find if this procedure using 2's complement generates any carry or not. So how subtraction is done in 2's complement form? It will be basically A minus B can be written as A plus 2's complement of B. So 2's complement of B is basically 1's complement of B plus 1. So we can write it down as, so this can be written as 1's complement of B is 0 1 0 1 plus 1, which is basically 0 1 0. So this will be 0 1 plus 0 1 1 0. So the answer here is 1 1. Sorry, it will be 0. 1 plus 1 is 0. Carry is 1. Again 1 plus 1 is 0. Carry 1 1. So no carry is getting generated. Also note this is a negative number, so 2's complement of this will be, so if you want to find 2's complement of this, it will be 0 0 1 0 plus 1, it will be 0 0 1 1. So it is a negative. So no carry is generated. So answer is option B. So next question is, so we have two 8-bit numbers, R1 and R2. R1 is 56H, that is hexagon number, and R2 is 27H, it is also a hexagon number. So we need to find the value of R1 minus R2. So R1 minus R2 is basically 56H minus 27H. So this 6 is greater than 7. So basically this we have to borrow 1. So if we borrow 1, it becomes 16. 16 minus 7 is basically 16 minus 7 is basically F, because it is not 16, it is basically 6. So 7 to 6 is 6, and 7 8 9 10 11 12 13 14 15, that is 9 plus 1 2 3, that is 8 plus 0 1 2 3 4 5 6. So 8 plus 7 15, so that is F. The difference between those two is F, and the borrow 1 is here, so it becomes 3, so it will be 2F H. So correct answer is option D. Fine. So now let's go to the next question. So consider a NMOS transistor. What should be the value of the input for which the transistor is in conducting state? Assume logic 1 corresponding to high voltage and logic 0 corresponding to low voltage. So the theory says if the transistor is in conducting state, the input to which should always be logic 1. So the correct answer is option A. So this is a bit theoretical. So now let's go to the next question. So this is question 7. So consider the figure below. What is the value of F when A, B, C value is 101 and A, B, C value is 011. So we can write if equals to A plus B for the NOR representation, NOR plus C bar for the NOT of C and the whole NOT. So again we will apply the De Morgan's law. So this will become A bar B bar plus C bar whole bar A bar B bar C bar bar A bar plus B bar C equal to A plus B C. So value of F for 101 will be 1 plus 0 into 1, so it will be 1, and value of F for 0, 0, 1 should be 0 plus 0 into 1, so value will be 0. So the correct answer is correct answer option is option A. So now move to the next question. So the next question is how many distinct switching functions for three variables are possible. So the standard formula for this is 2 to the power of n for n number of variable so how does this formula come? So suppose there are n variables, so n variables 1 2 3 dot 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 n. So if we can pick any number of variables from them to form a literal. So the total number of combinations is 2 to the power of n. So here there are 2 to the power of n literals, and here there are only two values possible for each of the equations, that is 0 or 1. So the total number of mappings for this will be 2 to the power of n. So for value 3, for n equals to 3, it will be 2 to the power of 2 to the power of 3, that is 2 to the power of 8, it is 256. So correct answer is correct correct option C. Now let's move to the next question, question number 9. The question is, which of the following representation represents the correct order of memory in terms of speed, fastest to slowest? So the memory hierarchy is somewhat sort of a triangle, the memory triangle. So let's divide it to 4 parts. So at the top of the pyramid is registers, then there is cache, then there is main memory, then there is secondary memory. So the fundamental is, as we go down, access time increases. And as we go up, cost increases. So naturally the register is much faster access compared to cache, main memory and secondary memory. So the correct option is option A, register, cache, main memory, secondary memory. So option A. Now let's go to the last question. The question is, what is the typical main memory capacity in a desktop computer? So the natural answer is option C, sorry. So naturally the modern desktops have 4 GB, 8 GB of RAM. 40 GB is basically mostly for workstations. So with that we end this week's questions and live session. Feel free to ask any question in the chat and I will reply to it. Thank you.